Good morning. My name is Uma Maheshwari. I am here to discuss about the topic of PIC interrupts. It comes under the PIC microcontroller 16F877A. Here, the types of interrupts we will see. First of all, the types of interrupts, and it is being used in PIC microcontrollers are timer interrupt, peripheral interrupt, real-time processing and all. The uses of interrupt. What for this interrupts we just want to learn. Like this is for uses is nothing but the real-time processing, event-driven application and power management, peripheral control, etc. So for these things we need the peripheral, we need the interrupts. Here, what is an interrupt first of all? Here, the PIC interrupt is nothing but it refers to the signaling system. It is a system like the PIC microcontrollers that has been temporarily halts the main program to execute a special routine called an interrupt service routine when a specific event which has been occurs. These events can be an external one like or internal one. When the interrupt reaches happens, the microcontroller saves the current position in a current state, and it is jumps to the ISR, that is the interrupt service routine, to handle the event but that has been coming inside, and then it restores the state to continue the main program where it has been left off over there. Like the interrupt process is nothing but the event occurrence context saving and then the jumping to the ISR execution, return from interrupt and then resuming the program. These are all the things I have told right now. The process is nothing but when there is a flow of the program, when the interrupt occurs, it will just gives that control to the interrupt service routine. And once the interrupt service routines process has been get over, and next it has been disable the interrupt, that is it should disable, and it is saves the processor state. And next one is to the interrupt handling part should be there, and from that interrupt handling part it restores the process state and enables the interrupt. These are all the steps to handle the interrupt. Here in this case the key components are nothing but here interrupt service routine vector table. Interrupt vector table is also there, that is also called as an IVT. Here the interrupt enable bits and the interrupt flag bits and then priority bits is also there. Here we can see like these are all the speed control, induction motor, max 232, and then temperature sensor, buzzer. These are all the things like if this happens in the PIC microcontroller, we can go for this interrupt. Say for example, if there is any communication part that has been coming inside like transmitting bit or receiving any something, receiving bit means we will be going for this communication protocol by using this Zigbee and all, and the induction motor, speed sensors, and then the LCD. Even in some cases the power supply is also called as a interrupt. Here the buzzer is also there and the current sensor. So these are all the interrupt. Here the core components is nothing but here oscillators are used to count the time. Here in this case the timer, that is the time delay, is also used for handling the interrupts, because the timer of that particular interrupts is a very important point, a very important feature we should be considering to account. Here the program halt is like the microcontroller's main program is temporarily passed and the current status of that CPU is saved to a stack. Jumping to ISR is nothing but the program counter is directed to the address of the interrupt service routine, that is ISR, associated with the event. Here the ISR execution is ISR code, it has been executes to handle the specific event. How to resume the program. Once the ISR has been finished, the microcontroller restores the saved state and it has been continues the executing the main program from the point where it has been interrupted. This is the sample code I have taken for this for explanation. Here the hash includes 16F, PIC 16F877A.h is the header file. And here we have seen like the oscillator selection and all. The pragma, this is for watchdog timer, and the interrupt void underscore interrupt is nothing but your function call for interrupt, and then intf is if it is equal to 1 means we'll be going for this to toggle the LED, and it is for next line is for clearing the external thing. Here the void main, the main program is for port B is equal to 0x00. That is, we have taken the port B as our communication part, like outside world. We just want to communicate, means we will be going for this port B only. So the tris B is nothing but your corresponding register for that port B, and GA is your global interrupt one, and the application of this interrupt is nothing but your improved responsiveness and then efficient processing. The efficient is main thing will be going for this interrupt. So the modular design, security system, keypads, robotics, etc. Here I have given some questions for assessment with answers, so you can go through this. And this is the summarized part. This is how the memory is been working while the interrupt process going on. And then classroom activity, this is some fun activity, and the references, these are all the references I have taken for interrupt, particularly pick guides and then interrupt part. So thank you. We'll see the next topic in the next video.